All right, so what we're going to do today is just do one section. So today's notes will be kind of short, and then we'll meet again tomorrow to finish up the notes. And then we'll start reviewing, getting ready for that test that we're going to have over this chapter next week. Any questions or anything you want to talk about before we start this last section here? You guys did good on your homework quiz. It seems like there were only a couple little things here and there. I think the biggest thing that was missed was the electrons. Like some people didn't count the electrons the right way, so we can review that before we take the test again if you need that. But other than that, people seem to have a pretty good handle on how to balance redox and how to do those voltaic cells. So what we're going to look at today is we are going to bring back the free energy variable, so delta G. We're going to bring back K again, and we're going to look at how all three of these things kind of interact with each other and how they can all be used to determine whether something is a spontaneous reaction. So the first thing we're going to look at is how they are connected here. So you can see the relationship between all three of these. So a couple of these, or at least one of these we've used before. So this equation here should look familiar. That's the one from the last chapter, that negative RT ln K. So that was how we relate G and K. We can relate delta G, again, which is the free energy constant, and E cell by using this new equation, delta G equals negative NFE E cell, and we'll talk about what that new variable means in a second. And then the last relationship is between E cell and K, and this is the other new calculation that we'll learn how to do today. So depending on what you're given, you can still calculate K for a reaction, you could still calculate G, and now that we've thrown that E cell in there, there's a couple other options for formulas. So that's what we're going to work on today. So when we're looking at this, we're gonna, again, G means the same thing as it did before. So if something is spontaneous, if something is happening without outside intervention, G has to be less than 0, it has to be negative. We talked last week about how E cell has to be positive for something to be spontaneous. And then K has to be greater than 1, again, meaning that that reaction is headed in the forward direction or it lies to the right. So that's how those three things can relate. If it's non-spontaneous, then G is positive, E cell is negative, K is less than 1. So the K value, that's the same standard as what we've looked at before. The G, that's the same standard. Now we're adding in that E cell. So all three of these things should go together. If G is positive, E should be negative, K should be less than 1, and then vice versa for a spontaneous reaction. So this is that first new formula that we looked at. So delta G, we know that it could either be given or we could be given the G of formation where you have to solve for delta G using that summation equation like we did before. E cell could either be given or you could be given the values to solve for E cell using that cathode minus anode reaction that we've used. And then there's a new constant in this one. That one's called Faraday's constant. So Faraday's constant is the charge in coulombs. So coulombs is another measure of charge. So you may have talked about that a little bit in physics. So that's the charge of 1 mole of electrons. So 1 Faraday is equal to 96,485 coulombs per 1 mole of electrons. You may also see a lot of texts or a lot of reference sheets use 96,500 coulombs per 1 mole. So you can use either one of those. Those would both be acceptable values for Faraday. So again, this is a constant. So this would be something that would be given. So to solve for either G or E, all you need is one of those two other values. N is how many moles of electrons are transferred in a reaction. So that N value would be like the electrons that you cancel out. So when you were doing those balancing redox reactions and you had 2 electrons on each side, that N value would be 2. So it's whatever the value of the electrons that gets canceled out. Okay, so let's try one of these. So this one says, use the electrode potentials, which means we're going to have to go to our reference sheet for that. So that's where those are going to come from. to calculate delta G for the reaction, and then we want to know, is the reaction spontaneous? So I know that I'm going to use delta G equals negative NF E cell. And notice for now, we're still using standard E cells. Tomorrow we'll talk about how to deal with E values that are not under standard state, but for today we're still talking about standard E cells. So we're still using that reference sheet. So I know that my delta G, and again, this should be a standard G. That's what I'm solving for. And I'm gonna figure out in a second when I split this reaction up. F is a constant, so I'm using that 96,485 joules per coulomb. Or I'm sorry, coulombs per mole. And then I am going to have to calculate this E cell value. So these can be a little more complicated because I got to do a little bit of calculations before I can actually plug these into the formula. So what I'm going to have to do is take this equation up here and split it into its two half reactions. So I know that I2 is going to go to 2I minus, and the 2Br minus is going to go to Br2. So this is already a balanced equation, so you don't have to worry about balancing it. But what I do have to do is I have to figure out what the E cell value is from those half reactions, and then I also have to figure out how many electrons are transferred. So let's start by looking at electrons transferred, because this is usually pretty easy to figure out. So over here, this is a 0, and this is a 2 times -1. So that's a -2. And the electron should be the same in both equations. So this would be 2 times a -1, and this would be a 0. So the only way to get those charges to balance is add the 2 electrons over here, and then add the 2 electrons over here. Okay, so that tells me my N value is 2. So that's how many electrons cancel out when those equations are added together. Okay, the other thing I can figure out now, since I know where the electrons are, if the electrons are on the left, that means this side is being reduced. So a gain of electrons is reduction. So that means this is my cathode. Over here, I'm losing electrons. So this is being oxidized. So that means this is my anode. Okay, the reason we care about that is because that's what we're going to use to calculate that E cell value. Okay, so to calculate E cell, I have to first look up the values for these reactions. So I'm going to go to that chart. So this one is going to be 0.54 volts. So these numbers here are coming from that reference chart or reference sheet that's in your notes. So the same place we got those values before. This one down here is 1.09 volts. Okay, so then to get my E cell, before I can do that final calculation, I'm going to take cathode minus anode. So my cathode is 0.54 minus 1.09. So my E cell value is -0.55 volts. So that's going to go over here. Okay, so before we move any further here, any questions on where any of that stuff came from?
No.
Very good. So the N value again, I got that by splitting it up into half reactions and then looking and seeing by looking at the charges, what were the electrons that canceled. I identified what the cathode was, what the anode was, depending on which one lost electrons, which one gained electrons. I looked those values up from the reference chart so that I could calculate E cell. So then now I have everything I need over here to be able to calculate G. Okay, so I'm going to erase this little section here so I have some room to do my work. Okay, so then delta G is what I'm solving for. So -N, my N value is 2. My F value was 96,485 coulombs per mole. And this is 2 moles of electrons. That's what gets rid of that mole value. and then my E cell was negative 0.55 volts. Okay, one other piece of information to know here is that a volt is the same thing as a joule per coulomb. So that's how I'm going to get rid of the coulombs and end up with the joule value that we're familiar with for our G value. So what I'm going to do here is I'm actually going to rewrite this as negative 55 joule per coulomb. And again, I'm doing that because a volt is actually a derived unit and it comes from a joule per coulomb. So then if I look at my variables here, moles goes away, coulombs goes away, and that's where I end up with my joule as my final unit. Okay, so delta G would then be 1.1 times 10 to the 5th joules. And then if you wanted to change it to kilojoules, you could, but you don't have to. And then my last question here is this reaction spontaneous? So I'm going to look at the overall sign of delta G. Now I could have looked over here and said, okay, so E cell is negative, so G should be positive, but you always determine this last question from your final calculation. So this would be not spontaneous, and that's because delta G is positive. Okay, so pretty simple formula to start with, but sometimes on these there's a lot to do before you get to the point where you can actually plug stuff into the formula. All right, any questions on that one before we do the one other one today? All right, so the other one, the process for this one is similar. So you have your overall formula. So this one is E cell equals 0.0592 volts over N. N is still your numbers of electrons, log K. So now we can look at, if we are able to calculate the E cell, how can we get the equilibrium constant, which is what K is again. So in order to do this, we either need to know the K value, and then we could solve for E cell, or if we have E cell, then we could solve for the equilibrium constant. N is still numbers of electrons. We're still on most of these going to have to calculate E cell if we're solving for K. So kind of a similar process, but it's just asking for something different and it's using a different equation. Okay, so here's our overall question here, example for this one. Tabulated electrode potentials. Again, that comes from the reference chart that's in your notes. And again, just so everybody knows what I'm talking about here, that's this chart right here. So that's where those numbers are coming from. And I'm solving for K, and it gives me the overall reaction. Okay, so again, to do this, I'm going to use E cell. And again, this is still a standard value. Tomorrow we'll talk about non-standard. 0.0592 volts over N log K. So in order to do this, K is what I'm solving for. E cell, I'm going to have to do the same way as what I did on the last problem. And then N is still numbers of electrons, and I'm going to find that the same way as well. So I'm going to split my equation up here, and I'm going to use a different color just so we can maybe see this a little better. So Cu goes to Cu plus 2, and then 2H plus goes to H2. Okay, so let's do the electrons first, like we did in the last one. So this one is 0, this one is plus 2, this one is plus 2, this one is 0. It's not always going to be 2, it's just for these couple examples, it just happens to be 2. So this one, you're going to have your electrons over on the opposite side. I don't know why I keep doing that. Okay, so I need 2 electrons over here. And then for this one, I need 2 electrons over here. Okay, so that tells me my N value is going to be 2 because the 2 electrons cancel out. Next thing I need to figure out is where's my anode and where's my cathode. So on this one lost electrons. So this one is oxidized, which means this is my anode. Remember anox, red cat. This one is gaining electrons. So that is my, that side's being reduced. So that is my cathode. And again, I need that because that's how I'm going to calculate this E cell value. Okay, so then I'm going to go to the chart and I'm going to look the values up for these, and I'm going to put these values on the other side so I don't write over people's names on the other side there. So for copper to copper plus 2, be careful with copper because copper's on there a couple different times for different charges. So make sure you're pulling the right copper off of that chart if that's what you're using it for. So for this one, it's 0.34 volts. And then this, the H, is that standard hydrogen electrode that we talked about. So that value is actually 0 volts. So that's the one that everything else was compared to. So then to get the E cell, cathode minus anode, so 0 minus 0.34. So my E cell is negative 0.34 volts. And be real careful with your negatives and positives on this because that is going to have an effect on that overall answer. So you want to make sure you're careful with those. Okay, so that starts out just like the other one did. So now that I'm finished with that, I'm going to erase this. And now I can go and plug all those values back into the overall formula. So my E cell value is negative 0.34, 0.0592 volts per 2 moles. I'm going to put the units over here, 2 moles of electrons. And then log K. So the first thing I have to do is get the log K by itself. So I'm going to move all this other stuff to the other side. So I end up with log K equals negative 11.486. And then to get the K by itself, K is going to be 10 to the negative 11.46. And then that final K value is going to be 3.3 times 10 to the negative 12. Okay, and so now this one didn't ask about whether this was a spontaneous reaction or not, but we know E cell is negative. That tells us it's not spontaneous, but again, we're always going to look at that final value. So K is less than 1, so this would also be a non-spontaneous reaction.